vertical displacement. Instead of vertical translation, for trig we say vertical displacement, 3 up. We agree? What's our mapping? X, Y becomes. Did anything happen to my X? Nope. My X stays an X. My Y, all I did was move 3 up. All I did was move 3 up. So what am I going to do to my Y? Yeah. Y plus 2. I'll tell you right now, this lesson is really easy if you're good at transformations and really bad if you're not. Because it's just transformations again. The difference is vertical displacement, horizontal phase shift. That's it. Still all the same rules. Get in Y equals. Your horizontals all flip. Your verticals do not. Right? Okay. Now, if I have an amplitude is affected by my Y's, right? My amplitude of my graph, my sine and my cosine graphs are normally at -1 and 1. What's the only transformation that's going to make that change? To make it taller or narrower? What would I have to physically do to the graph? Pull it up or squish it down? Vertical stretch. Vertical stretch is the only thing that's going to affect my amplitude. Wait a second, the vertical stretch is the amplitude. Remember, the amplitude is the absolute value of A on your equation, right? Did my A change at all in here? My A is 1. So my amplitude, circle whichever had changed. This did not change. Now my range, let's see. My range is normally between -1 and 1. We said that yesterday, right? I've now moved it 3 up. So I'm taking my graph from -1 and 1, and I'm moving it 3 up. Did my range change? Yep. It's not -1 and 1 anymore. It's moved 3 up. So now it's going to be at 2 and 4, right? Because -1 and 1 is a distance of 2. And move -1, 3 up, so it's going to be between 2 and 4, right? So the range changed. Did the period of the graph change? Where do I get the period from? From the period. I get the period from the period, remember? The period is 1. Whatever in front of my X. The period is 1. So 2 pi divided by 1 is 2 pi. Did it change? No. My B has to be, I have to have a horizontal stretch. Remember? Changing my amplitude is that vertical stretch. It pulls it longer or narrows it. Period is based on my horizontal stretch. If it's 1, it hasn't changed. It's still 2 pi. That didn't change. My domain doesn't change because it's XER. So let's give you restricted ones. Nothing has changed in XER. I'll select. My x-intercept. Anything on my x-axis is now moving 3 up. Is my x-intercept changing? Yep. Anything on my y-axis is moving 3 up. Is it changing? Yeah. So both of these are going to change. The key thing for your x and y intercepts, they're going to change whenever you have a vertical or horizontal translation, or vertical displacement or horizontal phase shift. Because then you're moving them off of their spots, right? You're moving up and down, you're moving them left and right. You're going to change your x and y intercepts. Now, how do we get our range? This is where I would pull that formula sheet back out again, the one where you're writing formulas on it. And pull that sheet back out. How could the range be obtained? Well, let's think about it this way. You don't have to do this, I'm just showing you something extra. So you understand why. Okay. Say I have a midline, and we talked about midlines, we said the midline is a D back value, right? So say I have a midline, a D value at 3, which is what I do, right? My D value is 3. So I have a midline at y equals 3. We agree? Because the D is at 3. What's my amplitude of my equation? Rewriting my equation here so you can see it. Sine x plus 3. So this is my D. My amplitude is 1, isn't it? Correct? Because it's the absolute value of A. So let's think about it. If I go from my midline, if my amplitude is 1, it's half the distance, correct? So if I go from my midline, which is half, what's the line that cuts the graph in half, and I go up 1, what am I at now? 4. And if I go down 1, what am I at? 2. Which is what we were saying earlier, right? Its minimum is 2 and its maximum is 4 because I moved it up 3, right? Well, how did I do that? I took my midline and I added my amplitude and it gave me my max, didn't it? And I took my midline and I subtracted my amplitude and it got me my min, didn't it? So what we can write on our formula sheet, if we ever need our range, our maximum equals D plus amplitude. You cannot get these backwards. People on the unit test will go amplitude plus D. It's wrong. Amplitude plus D works. Amplitude minus D does not. Your maximum will always work, and your min won't. Actually, it won't work for D. So max is D plus amplitude. Your minimum equals D minus amplitude, not A value, amplitude. And your range, just to remind you, your range in set notation is Y such that minimum value is less than or equal to Y, is less than or equal to your maximum, Y here. Can we type these in and look at what they look like too? Can you type like Y equals sin X plus 3 in our calculator and look at it? Sure. Find our maximums that way? Yep. But what if they give me an entire equation with A, B, C's, and D's and no numbers? That's why we need to know how to actually figure it out without just using our calculator. So how can we get the range of this graph? We could go maximum, which is D. Our D value is 3, plus our amplitude. Our amplitude is the absolute value of A. So the absolute value of 1 is 1. So if I go 3 plus 1, I get 4. My minimum is 3 minus 1, which is 2. So my range is Y such that 2 and 4 are sandwiched between what? So 2 is less than or equal to Y, is less than or equal to 4, Y here. For an interval notation, 2 to 4. That's one of those formulas that I keep these 3 formulas on that extra formula sheet to remind yourself. I need a maximum, and I'm given an equation. I will D plus out at a minimum, and will D minus out. If I need a range, I need both. Yep. So I'm going to call it and specify. And I'm going to specify the I have to accept the higher. And if I ask for interval, and you set, you would get anyone. So number 2, what are my translations on this one? Transformations on this one. Choose the very back of your X. No, so it's a vertical displacement. 2 down. How do I get my range? How do I get my maximum? Well, my D is -2. My amplitude for this one is what? Absolute value of A, which is 1. So I'm going to do maximum is D, -2, plus my amplitude, which is 1. So maximum is at -1. And my minimum is -2 minus my amplitude. So my entire graph, is it above or below the x-axis? Above or below the x-axis? It's below. I'm maxing out at -1 and I'm minning out at -3, right? And it's just bouncing between that. When I'm mapping, if I want to do mapping for this one, this would be 2 down. So my x, y is becoming x, not changing. And I want to move 2 down, y -2. The hardest part of this, 100%, is knowing your transformation. It has nothing to do with trig at this point. There's a bit, you can tell your amplitude and stuff like that, but it bases itself off your transformations being correct. For 3, what transformations do I have? What is this 3 in front? Vertical stretch by a factor of 3 above D. x-axis. Okay, so we can go stretch, reflect, translate. What's this 2 at the back? A vertical placement, what? 2 up. Well, x is by itself, right? Did anything happen to my x's then? No, so I go to mapping. The x got to be the correct part because there's nothing to it. What did I do to my y? Multiplied by 3 and added 2. Because vertical doesn't change. Vertical is the best. It doesn't flip. It changes sign. So we get 3y plus 2. My amplitude of my period sine function is 1. So 1 up from 0, 1 down from 0 is 1. Okay? Did my amplitude change on this one? That's my amplitude. 3. It's just the opposite value of A, right? My amplitude changed. Did my range change? My range is normally for pair functions between -1 and 1. Well, the amplitude is for sure 3, so it's for sure changed, right? I also moved it 2 up. My range is going to change. Is the period going to change? The period is affected by what? Horizontal stretch, your period, remember? Which is the B value affects my period, which is the horizontal stretch. The horizontal, I don't have one, so that didn't change. The domain didn't change. The moment I'm moving 2 up, my x-intercepts, wherever they were, are now lifting up. Remember, the moment I move 2 up, no matter where my y is, it's lifting up. So both of these are going to change. What's the range? Well, my maximum. What's my D? My D is 2. My amplitude is the absolute value of A, which is 3, so it's 3. So my maximum is D plus A, which is 5. And my minimum is D minus A, which is -1. Could I type this into my calculator and find maximum using my calculator? Yep. Unless I take away every number and put variables in there. So that's when we really need to know this formula, is when they pull the numbers. They don't allow you to calculate. So my range is from -1 to 5 in interval notation, or in set notation. -1 is less than or equal to y, less than or equal to 5. If your symbols are ever in the opposite direction, you made a mistake. If you have 2 numbers between 2 values, they have to both be less than signs every single time. You're like when you have flip them, you don't. Not for sign flipping, yeah. We're going to go to number 5. Number 5, what's happening? Horizontal translation, which is actually called a horizontal phase shift. Yep. Because our stretch is in between, the stretch is found between cos and x. Because if we look up here, cos, x, are b's in between. And it's nice because they actually give it to you, right? They give it to you right on the bottom of your formula sheet, so you can look and see where A, B, C, and D are, right? So this is technically actually C. A is 1, B is 1, C is -5/2, and well, C is actually +5/2, and D is 0 technically, right? If there isn't anything. So the only thing I have is a horizontal phase shift. pi/2 to the what? This is one of those again where you're going to have to remember you have to have a 1 in front of your x or your horizontal phase shift will be wrong as well. Remember, you have to take that GCF out. This one doesn't have one. Here. Does the amplitude change on this one? No, because the amplitude value of A. The absolute value of A is 1, right? Don't did it change? Did my range change? Starting at 0, going up 1, starting at 0, going down 1. That didn't change. But we can check it over here anyway. Did the period change? Period is based off my period, which is my B value. My B value is 1. So unless my B value is not 1, the period is not changing. Right? It's not being stretched in or stretched out. That didn't change. Like the range didn't change. My x-intercepts. So anything on the x-axis is moving pi over 2 to the right. Are they changing? Yeah, my y-intercept, something on my y-axis is moving pi over 2 to the right. You're pulling it off the y-axis, correct? So both of these are changing. So the moment you have a vertical or a horizontal translation, okay, a vertical displacement or horizontal phase shift, your x and y intercepts are moving. Okay? Maximum is d, which is 0 in this case, plus 1, so it's 1. And my minimum is 0 minus my amplitude, so -1. So my range for set notation is -1 is less than or equal to 1, is less, yeah, less than or equal to y, is less than or equal to 1, y-er, or -1 to 1. So we're not doing anything crazy here, right? The hardest part is not making the transformations. Okay? Now, let's look at these ones. This is in degrees. You see the C value, it's in degrees. If you were to type that in your calculator, it has to be in what? Degrees. This one is in what? Radians. So your calculation has to be in radians. Oh, and keep this in mind too, whenever you press the button sign or code, a bracket pops open, right? So you're going to have to make sure to put a bracket behind these. So code, you're going to press that button, a bracket's going to open. You have to make it have a bracket close. The moment you press the button, the bracket pops open. Okay? So what's the transformation for this one? Horizontal stretch, we have a B, period, right? I was filling all my letters to make you feel better. So A is 1, B is already something, C is already something, D is 0. This one, A is 1, B is already something, C is already something, D is 0. So if A and B don't have numbers, they're 1. If C and D don't have numbers, they're 0. Right? So this is a horizontal stretch. By a factor of what? Of 2. Always flips. About the opposite axis. So if it's with the x, it's about the y-axis. And we have a horizontal phase shift. $30 degrees. Don't forget your degree symbol, or it's a radian. It's really large. 30 degrees left. So if I went to do mapping, x, y would become 2x minus 30. Remember, it's always the opposite with words and with mapping because they're the same. 2x minus 30 degrees. And my y are these things? They didn't change. Is my amplitude change? My amplitude is the absolute value of A. My amplitude is the absolute value of 1, which is 1. Remember, I tested for amplitude. You can't write down. It's a matter of 1. So my amplitude did not change. Did my range change? Start at 0, go up 1. Start at 0, go down 1. No. The period changed. Yep. It's normally 360. Why did I say 360 and not 2 pi? Because I have degrees. So my period of this one's only 360. It's now being stretched by 2. So what's it going to be? 720. Your horizontal stretch graph will tell you what you need to do with the period, right? You can memorize P equals 2 pi over B. No, could you? Sure. You divide by half, it's a whole time by 2. That'll work for you. Use the formula, absolutely. So this is going to change. It's going to actually equal 720. My domain isn't going to change because it's XCR. So unless I restrict the domain, it doesn't matter what you're doing. Do I have a vertical or horizontal translation happening here? With the vertical displacement or horizontalization? Nope. What's going to happen to X and Y intercepts? They're going to change. What's the period of the graph we already gave? It's 720. And I want to do the range. So my max is D plus my amplitude. D is 0. My amplitude is 1. So my max is at 1. My minimum is 0 minus 1, which is negative 1. So I get y such that negative 1 is less than or equal to y. Less than or equal to 1. Y, yeah. And maybe 1 and 1 for interval notation. What we have left in the unit is tomorrow I'm going to give you actual graphs and words. It's going to have to come up with the graph of a trig function and you have to come up with the equations of them. I'm going to do the words of transformations and you put the equations just like we did in transformations, right? Then you do mapping and you come up with the equations as well, right? Those are back. But graphs and equations is where people struggle. We're going to think in hacks tomorrow so we can make our equations really, really good. And then all we have left after that is word problems. There's only 2 left in chapter 5. And you test it on. Okay? So the homework for this one is page 250. When it says sketch a graph, sketch one graph, call it a day. Don't sketch all of them, that's insanity. Okay? But sketch one, so I know you don't have to type in your calculator and get some, right? I'll sketch more, power to you. That's up to you. Okay. So I want you to do number 1, E, E, and F. There's a little hint with E. You have to take the GCF out first or your horizontal phase shift is going to be wrong. So for E, it says 6x plus 30, all in brackets. You have to take the 6 out, and then you're going to have x plus 5 degrees. You have to move 5 to the left, not 30 to the left. So remember, take that GCF out, so I need to have a 1 in front of my x, just like in transformation. That's on E. Number 2, DEF. Same thing's going to happen for F on this one. You're going to have to take the 2 out. Number 3 and 4.